Okay, let's get this started. So, good morning and/or afternoon to everyone. Welcome to our webinar, Modern Network Compliance: Achieving Compliance in a Hybrid Multi-Cloud World. As a quick intro, my name is Glenn Gray. I'm the Director of Product Marketing here at Itential, and I am joined by our resident network engineering guru, Rich Martin. Say hi, Rich.
Hello, everyone. Hey, Glenn.
All right. So before we get started, a couple of housekeeping points to discuss. Everyone on the call is going to be muted. If you have any questions along the way, aside from Rich and I, of course, we will not be muted, hopefully anyway. If you have any questions along the way, please drop them in the questions panel, which you can find under the webinar. We'll do our best to answer questions along the way and cover any remaining ones at the end during our Q&A session. If we don't get to all the questions in this webinar, we will answer them via email shortly after the webinar. All right, so let's get started. So, quick agenda here. A lot of what we're going to talk about is just sort of recapping what we've discussed in the last two webinars in this 7-webinar series. And then we will cap it off with a demo. So to begin with, we're going to talk about, we're going to recap the subject of modern network compliance and what the drivers are. This will be really important to kind of set up the demo that Rich is going to do for us. We're going to talk about why cloud networking should be on your radar if you're a networking engineer. And what does cloud networking look like? How does it differ? Does it differ significantly from traditional CLI-based networking? And if so, how? We'll talk about how cloud services have added a great deal of complexity to network, to managing and enforcing network compliance. And then we'll cover the 3 key components that we've covered in the last webinar that are key to achieving compliance on modern networks with modern topologies across CLI and cloud-based infrastructure. And then we'll have our demo and we'll finish up with a quick Q&A. So let's get rolling here. So we've talked about in the past couple of webinars, compliance. What does compliance mean? Well, compliance really is, for any organization, the adherence to a set of standards, a set of unique standards that an organization designs for its networks. And those standards tend to fall into the 3 categories of security, reliability, and performance. So what drives an organization to design those standards? Well, a really easy one is external regulation. So you think about HIPAA or PCI DSS or something along those lines. Those tend to fall into the security category. But those inform how those standards are designed, and for fairly obvious reasons. Now, also in security, you'll have sort of best practices and things like that fall in there. But these are just some examples of what might drive an organization's compliance and network standards. So reliability, right? I mean, you need to run the business. So we're talking SLAs here, network uptime, things like that. And then, of course, business strategy, which can inform performance, reliability, and security, but primarily in the performance category. So if you're an organization that is delivering applications, an organization that is in retail or something along those lines, performance is a really super important part of your network compliance standards. All right, so cloud or network engineers out there, why cloud networking should be on your radar? Let's talk about that, Rich. So why should it be on your radar if you're a networking engineer?
Yeah, now we're getting to the good stuff. Well, let's look at it this way. Whether most organizations recognize or not, from the networking perspective, it's happening in your environment. And what we mean by that is, if there's any deployment of cloud applications going on within IT, I guarantee there's some cloud networking that underpins it. And networking teams may not be directly involved with what's going on cloud deployments, but every time something gets deployed in a cloud environment or cloud platform, there's always some networking components that are spun up with it. And that being said, let's take AWS as an example. That's a great platform. And one of the fantastic things they've done is that's made them successful is to automate a lot of things. So when I spin up an EC2 instance, I'm also, as part of that process, spinning up something called a VPC, which is a networking element. And I don't have to be a networking engineer to spin that up. And so as more and more applications get deployed into the cloud, I'm using VPCs, and now the cloud ops team is probably scaling this out, and maybe they're deploying more and more VPCs. But at a certain point, you kind of hit a tipping point with being able, within all the cloud platforms, but within AWS, being able to, in a simple way, build networking up. But then you get to a point where it's like, okay, I've got to connect lots of VPCs, maybe in different regions. There's some limitation to the simple networking I started with, and now I need to bring in some more complex network native, cloud native networking into this mix because because of scalability, security, performance. And now I actually have to bring in some network expertise into this. Like, so something like a transit gateway in AWS includes the ability to do a networking protocol called BGP. Well, in the world of cloud ops, BGP is a foreign thing, but the world of networking, BGP, they've been doing it for decades, right? So bringing these teams together is eventually going to happen when that tipping point happens within an organization. And that also means that in the cloud networking world, there's a high level of complexity. So network teams that aren't already involved with what's going on the cloud side of things ought to be looking at it, trying to understand what's happening over there, because at some point they're going to be drawn into this, and it could be flipped over the fence and said, okay, hey, we've built all this cloud stuff out, now you help connect it together and manage it. And that's like inheriting an entirely whole new network that you didn't have anything to do with. So that's one of the big reasons that it should be on every network engineer's radar. What is going on in my organization's cloud deployments, and what does that network look like? And then when you think about the rate of change and how quickly you can deploy things in the cloud environment versus a traditional on-prem network environment, there's a vast difference in that. I mean, the whole point of cloud is how can we deploy things very, very quickly, spin things up and spin things down very, very quickly. And that's a different way of looking at the network, where when it's really fundamentally has been built on physical devices that take some time to configure and put into the network environment, where in the cloud we can spin things up quickly, connect things through software, it's all automated. And so networking teams need to take a look at what's going on and how they can adapt to this very quick velocity of change in the cloud on the networking side. And then I guess maybe this is the scariest part, Glenn, is that when you bring in this entire new network, cloud network infrastructure that was built by maybe the cloud ops team, and it's gotten to the point where it's so complex that I need networking expertise to help figure this thing out. Part of what was done there, or maybe most of what was done there, never had the concept of any kind of compliance standards in mind. Think about the cloud. It's all about automation. In the networking world, we understand implicitly that we should have a standard on our network devices. The configuration, the CLI configuration ought to have these kind of things in it. But in the world of cloud, especially cloud networking, there may not have been any thought to that. It was more about, hey, how quickly can we connect things into a VPC and VPCs together, and how many devices can we have in a VPC, until it finally kind of spins out of control and it gets a little too complicated for a non-network team to manage. And now not only do I have to learn all these things, these cloud native things that are network focused, but then I have to go back and say, are they configured correctly? Do they meet a requirements, the standard requirements that we have that were already built in the on-prem network? Now I have to go back and say, what does the cloud networking look like in regards to compliance?
Right. So basically the story here is that networking is happening in your organization, on the cloud side, and perhaps you're not aware of it. Perhaps you're already a cloud engineer and you're approaching Itential or another organization like Itential because you understand, um, the need for compliance. But the long and short of it is that the cloud networking is almost certainly happening in an environment that you manage. And the velocity of change that's happening in your cloud infrastructure is much, much higher than what we might have been used to in the past with the traditional physical networks. And really the long and short of it here is that we need to be able to bring the entire network, both CLI physical devices and cloud networking services into compliance to adhere to those standards that we talked about earlier.
That's right.
All right. So here's a good question, Rich. What does cloud networking actually look like?
Glenn, cloud networking looks like nothing. It's the cloud.
Ah, that makes sense. It's just a big white fluffy thing that floats through the sky. I got it.
No, no. Jokes aside, cloud networking is very, very complex. I mean, what we're looking at here is this concept of your network exploded on the internet. And so if you let's just take one cloud platform, again, AWS, but it's similar for all of the major cloud, platforms, Azure and Google Cloud. Um, they have a set of what I would call cloud native networking services, right? They're not devices, they're services, and they're unique. So the first thing is network teams have to start looking at each cloud platform that they may have, their organization, their IT group has deployed applications in, and get their minds around, okay, what are the networking services that underpin all of these applications? So now it's AWS has, its VPCs and, its transit gateways and its versions of, IPsec tunnels. And but in Azure, it's got a VPC, but it's really called a VNet, and it may or may not have a one-to-one correlation with different features and functions. A lot of times it doesn't. It has some things that are the same, some things that are different. The way you configure these things can be slightly different. And then going through that whole portfolio for every one of these is you start to recognize a network engineer. Wow, there's a lot of, just within the cloud platforms themselves, there are a lot of network services going on that are all kind of part of the portfolio things that I need to understand and understand how they work and how to manage them, how to configure them, ensure compliance, those kind of things. So that's just within the platform. So every platform that an organization deploys to, that's kind of a whole new portfolio of networking services. And by the way, these networking services grow every year for every single one of these platforms, because they're involved with differentiating their services from every other cloud platform. So AWS is going to deploy new and unique networking services as well as all the other platforms that they compete with. So that's just within that, ecosystem. What about things like network services that are not necessarily within a cloud platform? So you have this whole slew of, especially around security, right? It's like Zscaler, Volterra, being able to um, utilize these network related cloud services as part of securing this now modern network that's all over the internet. And on top of that, you're starting to see like there's these additional problems with, where are my apps deployed? Well, they're deployed maybe in multiple cloud platforms, right? Well, where are my users? Well, again, they could be on-prem, they could be at home, they could be in a coffee shop. And I still have my own data centers, right? A lot of organizations still need to locate some of their applications and data on their on-prem data centers. And so how do you connect all these things together? And so there's a slew of methodologies and ways to do that with something like Equinix, which allows you to, build through the cloud, build cross connects to different cloud providers to optimize performance for your applications and your users. There's other things out there, like every major networking provider or vendor out there is building like something called an overlay. So one of the first overlays that, we've worked with at Itential is Aviatrix, who builds this network overlay. So it's kind of like one common control plane that allows you to expand like a kind of a virtual network on top of multiple cloud platforms and on-prem. So there's a bunch of cloud native, cloud-based network services that that an organization may be using today or may need to leverage in the future. And so that's really what it looks like. And so if you take a step back, and look at this diagram, this is what modern networking looks like today and will continue to look like in the future.
It sounds complicated, and I think one of the things that you pointed out that is really important for us to drive home here is the idea that especially with public cloud networking services, something from AWS or from Azure, there's typically not a one for one analog with what you might be used to in the traditional physical space, right? So, what is a VPC, for example? Well, gosh, it's kind of a lot of things. It's kind of a router, it's kind of a LAN, it's kind of a switch. I mean, it kind of does a lot of things that you might associate with just three or four devices or device types and physical traditional networks. So and as you mentioned, when you go to another cloud platform like Azure, they'll have something similar, but it will bundle together different services and things like that. So, jumping from one cloud platform to another, and then thinking about it in the context of your larger network, like we're looking at here, you can see how it gets complicated really quickly.
Absolutely. That's right.
Well, adding to this complexity is the notion that a lot of organizations sort of work in these silos. And I think you touched on this earlier, Rich, where there tends to be, in a lot of modern enterprises, a cloud ops team that's separated from the traditional sort of network engineering teams. And a lot of times, there are things going on in the cloud ops side that the network engineering team doesn't know about, and vice versa, of course. And this is a really interesting stat that we pulled from some EMA research that was done out there. But 73% of enterprises have experienced security and compliance issues because of the siloed nature of these organizations. So I think this really drives home the point that it's important to have tools that can help you manage compliance across a broad swath of networking services and devices and things like that we just talked about on the last slide. And an Itential automation platform can do that.
Yeah, that's absolutely right. It's critical for network and cloud teams to start collaborating together, understanding that, in the past, maybe network was simplified and very easy to approach in the cloud, but now it's evolved, it's moved forward, and there's a lot of complexity, just like we've seen that has grown just in the last few years. That's going to require a high level of network expertise, and getting the networking teams involved with the cloud deployments, taking a look at how things are deployed and optimizing. That's what network engineers do, right? So they're just taking their skill set from what they've learned in the on-prem, and now being able to focus it into the cloud. But it also requires the need to have a new set of modern tools to help network engineers address all of this new cloud infrastructure.
Indeed, and I can tell you that in talking to folks on our sales teams and sales engineering teams, that this is a fairly common issue. In addition to that, we're also seeing a lot of customers come to us that are not traditional network engineers that are coming from the cloud ops space. So there is some breaking down of these silos, but this doesn't seem like something that's going to go away in the near term. And so I think it's something that both folks on the cloud ops teams and network engineering teams need to be cognizant of.
Absolutely.
All right. So let's talk about the three components. We're going to recap something that we talked about last time, but this is really important because when we get into Rich's demo, we're going to be demonstrating at least two of these. So let's talk about these. What are the three components to modern network compliance, in your view, Rich?
Well, I think what we really want to help our customers recognize is that there is definitely a need to more easily create golden configuration standards. I mean, even if we just take the traditional network on its own in isolation, and we look at the tooling that's been around for many years on that, I mean, there's a lot of room for improvement. And so that's one of the things that we need are better tools to build compliance, and to really do it in a way that involves multiple people or multiple groups. Because if we're going to interact with our colleagues on the network team and in the cloud team, being able to democratize that so that more folks can be part of that. I mean, that's really what we're talking about, is getting cloud and networking teams working together and getting networking teams the tools they need to operate in the cloud. So within the context of traditional, making that better for golden configuration creation, and then being able within the same platform to apply the same concepts and flexibility of building golden configurations for traditional CLI based on-prem devices and applying it to now these new modern network solutions, which include cloud networking, like we've talked about, but even like controller-based solutions like SD-WAN and some other solutions like that, where they're not necessarily, they may be physical devices, but they're kind of behind a controller, an orchestrator, a director, some piece of software that acts kind of as the brain that manages all the physical devices. And typically those are API driven. So being able to integrate all three of these pieces is important for being able to define and enforce a golden configuration. So that's critical, because that helps us build, it gives us the platform that networking and cloud teams need to enforce compliance across the entire network, because it's not just on-prem and it's not just cloud. It's got to be all of it. Second part of that is the ability to automate the remediation of compliance issues. I mean, think about this. Networks are big, right? Just traditional networks. We've seen customers with thousands of devices in their traditional on-prem networks. Now add to it all of the network services and constructs that could be part of the cloud side of things, and you've got an enormous amount of devices and services that need to have compliance built across all of that checked. But ultimately, knowing that something's out of compliance is only kind of the first half. How do you fix it? And in order to remove backlog, we need to have network teams need to have a modern way to create the ability to do remediation and fixing those out of compliance configurations on those devices and services, but do it in a flexible, automated way. I mean, there are going to be times where maybe certain configurations that are out of compliance can be fixed in a non-impactful way. There can be times where you may want to have some human oversight on that, or maybe it can be automated, but during a maintenance window with the appropriate pre-checks and post-checks to make sure everything works, and then roll back. And that's part of the automated nature of that, because then once you discover things, devices and services on your network that are out of compliance, you're not going to create a manual backlog of having to fix all of this stuff. And trust me, network teams already are dealing with backlog just on day-to-day things. Creating an additional backlog is not a solution. And when you're looking at compliance platforms, you need to be able to automate these things and integrate compliance and automation together. And then finally, I like to ask it this way: once I've spent all of this time and energy getting my network devices and services into compliance, how do I keep it there? I don't want to have to have this battle where things are constantly breaking and constantly our process is going in and fix it. There has to be a better way. And there is. And in our platform, we would say that's validation. So we should be able to ask, the platform before I'm going to propose a change to a device or a service on the network. Before I actually apply that change, I should be able to ask a resource, in this case, the configuration manager of our application, hey, if I take this configuration change and apply it to this device, does this bring me out of compliance? And then get a response back that tells you yes, it does, and here's the reason why, or nope, you're in compliance. And then building that into an automation so that we can create now the ability to automate changes that do really, really stringent compliance checks as part of the automation. And if the check is, if it brings something out of compliance, we have to actually have applied it to the device or service, so that keeps us from unintentionally or even intentionally breaking something. And so I think that is a critical part of kind of modern solutions to this compliance issue.
All right, well, let's jump into the demo where we're going to cover two of those topics. So Rich, just walk us through what we're going to see today, and then we'll let you drive and show us the platform.
Certainly. So today, a lot of times our customers ask us, how do we get started building these golden configurations? So I want to walk us through how to simply get started building a golden configuration, both for a typical Cisco iOS CLI device, and then how you can do the same thing for an AWS VPC. So again, this is a kind of the foundational networking component in AWS's cloud networking. And that's an API-driven device. So we get configured, it's managed through, we can manage it through API calls into AWS and then pull its configuration to see what it looks like. So we'll take a look at how we do that within the same platform. So we'll build the golden configurations for a CLI device. We'll run a compliance check, show you remediation, and then show you an automation that does the same thing. And then switch over and say, okay, we can do it with CLI, but we also have this network that's also cloud-based or API-based as well. How do we do that? And show you in the exact same applications how we can cover that as well.
That's great. So we're covering, just to recap, we're covering Itential's a unique solution to building and managing and enforcing golden configurations, and then the ability to automatically remediate something that is found out to be out of compliance.
Yep, that's correct, Glenn. Okay, let's start in the configuration manager. This is where we would have a federated inventory of devices. So that's what we're looking at the left. And I'm going to pull up a typical iOS device. And we have a colleague here. His name is Karin. And we're just going to imagine for a moment that Karin has a remote office and this is his router's configuration. Well, this is actually his router that we can manage in Configuration Manager. So I can load his configuration up in real time. And when I build a golden config, what I want to do is understand the CLI configuration, and that's what we're looking at here of his device. And I'm just going, for an example, I'm just going to pick out a couple of CLI commands because I want to keep this simple, but I want to give everybody the idea of how you can get started and how the how our system works for building a configuration. So I'm going to highlight this IP HTTP server command along with a couple of SNMP server CLI commands that are in his current configuration. So if I go into golden configurations, and I've already pre-built some golden configurations, this is where I define my standard for not just Karin's device, but actually other likewise devices here. So we have another a remote user that I've added to this named Greg. So we'll take a look at both of these. But what I want to do is point out this this golden configuration tree here. This is very unique because this is a model that we've created that allows you to build configurations and insert configurations at different branches of the tree, and they become inherited as you go down. And this is cool because in the past with traditional tools, there hasn't been a lot of flexibility in how you can configure these things and then apply them to different devices. And what typically ends up happening is you have just about as many quote unquote golden configurations as you do devices.
That just sounds like regular configurations to me.
Yeah, at that point, it's just you no longer have a golden configuration. You just have many unique configurations. And so the concept here is, how do we actually create a golden configuration? So you can think of it in terms of from very global, like maybe things that don't change or that are globally applicable to a lot of devices, to the very specific as you go down the tree. So if I start at base configuration here, and you'll see it's colored in blue, I've already added that IP HTTP server command into here. Okay, I want this to be more globally part of the golden configuration for all the devices that I want to use, this golden configuration as the standard, right? So if I go down into the next level here, this green level, well, I've labeled it remote office routers. So now I've added a new line. So it's inherited the IP HTTP server, but also I have a new line where I've added that SNMP community. Now I want all of my devices under this green section, remote office routers, to inherit both of these configuration lines. So it's gone from very specific, very general, like the IP HTTP server command, down to a little more specific. Now we're going to get to the very specific. So if I go down further in the tree and look at Karin's remote office router, this gets to be the most specific. I've added this orange line here that says SNMP server location, Karin's remote office. So this is very specific to Karin's router. There should not be another router labeled this. And so that's why I've created this, because in Greg's remote router, he's got a similar but unique line here that identifies his router as the remote office, Greg M's remote office router. But he still inherits all the configurations from above it. Now, I've just used one configuration in each one of these tree levels. Obviously, when you look at kind of a built out example, you're going to have lots of configurations in each one of these levels based off of, what's unique, globally needed, and part of your overall compliance policy. But I wanted to use that as an example just from the very beginning. Does that track with you, Glenn?
Indeed, it does.
Okay, good. So if I go back to Karns, now we can take a look at a compliance report. And let me actually say that there's actually a bit of a problem right now. If I think about either common best practices for security or any of the kind of the compliance policies like HIPAA or PCI, there's a need to disable management services on any networking device that's not needed or specifically that's not encrypted, right? And so right now there's a problem. This IP HTTP server is a configuration line on a Cisco device that actually turns on the unencrypted web service so that you could manage it, but it's not encrypted. So we actually don't want that. That's a bad thing. So if we update our configuration here, I can highlight this and I can give it a disallowed tag. So now I've created a rule that says this should never exist on any of the devices that inherit this rule as part of the golden configuration for these devices. And then I can pick a severity. I'm going to pick an error severity here, which is the highest level of severity. And then if I save that and I go back to Karns router here, you'll see that now that's been updated and it's been inherited all the way down. And so now this has become my golden configuration with that change. And if I go to manage devices, I actually can now assign Karns router to this branch. And that configuration that we just saw becomes the standard by which his router's config will now be compared to. So I can run a compliance report now. And because we know that unencrypted service was turned, that HTTP service was turned on, now this device should show up as no longer in compliance. So if we look at the compliance report, we'll see that there was a failure there. We can look at the specific line. This is a disallowed config. So we just made this something we do not want to occur. It generated an error. And if I wanted to correct it, I could simply click that line, click remove, and then apply this. And now it's going to go through the process of remediating it. Now, we would say this is a manual method of remediation, Glenn, but technically there's some automation going on behind the scenes here. A networking person would normally have to CLI in or telnet. No, not telnet, SSH
No
in.
telnet.
Right? SSH in, make the changes, that kind of thing. And so we're actually doing a bit of automation, even though this was part of a manual process. And so we just got that back that said that it's been changed. If I run another compliance report, now we should be back in order again. So does that make sense so far?
It does. It does.
Okay.
And like our webinar viewers, I'm sure I want to see it in an automation workflow. So I'm
Sure.
hoping that's where we're going next.
Yeah, there it is. So let me make one more change here. So I'm going to go to the remote office routers, and part of a typical baseline security is also making sure that we have some sort of control on what device, who can manage this particular device. Meaning, a lot of organizations have specific, secured servers, jump boxes, jump servers, where maybe you can VPN in that device in a secured way, and then only that device can be used to connect directly through these management methods like SSH or secure HTTP to different network devices. And typically, I mean, this is just an example, but typically you would define an access list on a Cisco device. And again, this is just an example to show, perhaps we have a secured server that exists at 10.0.0.99. That's its IP address. And we would want to start to build out a configuration, a compliance template that specifies that only devices can be, from this particular IP can be used to connect directly to this device and manage this, not just this networking device, but, any networking device. And so if I add that in here and make it a required rule, which it is, Now I've updated the compliance template, and we could again run a compliance report on that. But like you said, we really want to see this in an automation, because ultimately, compliance and automation, they really do go hand in hand, especially in the modern network where we talked about so many devices and so many services running today. So in this automation, Glenn, is actually doing exactly what we just did in the configuration manager. We're going to run a compliance check for that tree. So it's leveraging everything we've done. And in the compliance golden configuration tree, we're going to get the output of the compliance report. The queries are just pulling information out of these API calls. Every one of these tasks is an API call. This blue box allows us to stop, have some human intervention. I put this in here on purpose so that we could stop and take a look at the data. And then it also allows us to make a decision. Do I want to remediate, or do I not want to remediate, essentially?
That's interesting. But to be clear, if you wanted this to be a fully automated remediation, you could pull that pause out, couldn't you?
Absolutely correct. Absolutely correct. And that's what I'm talking about, the flexibility. So as I start this up, let's take a look at the job, and we can view it running. And we can take a look at it. So right now it's running through the compliance report process. It'll quickly go through the queries, get the compliance report, and now it's stopped at the view data. So that's a manual task. So I can go in here and I can open up the manual task, because it's literally sitting here waiting for me. And if I work the task, what we see here is the report, the response from the compliance check. Now, of course, this is in a JSON object, so it's very much viewed in a way that's more programmatic and human readable, but we can parse it very quickly and look at it. And so what I'll point out here is that the compliance check failed, obviously, because why? I put in that access list, which is what you're getting here, access list 4 permit 10.0099. That was required. And so it came up and flagged this as, hey, this does not meet the compliance requirements when we looked at that particular device. And so now I can remediate or do not remediate. But for this, I'll just not remediate here. And then we can take a look at that task, the entire workflow, and see the automation path it took. So that's going from config manager, building a CLI based golden config in a very simple but very powerful, flexible way, and then running that within the configuration manager, showing the config check, the compliance check, and then being able to remediate, and then allowing in the same platform an automation to run to do just that. And again, this is a very direct and simplified way, because as you start to look at further automations in the platform, a lot more can be added, a lot more logic, a lot more systems, and those kind of things. But it's important to kind of grasp these core concepts. And this is just the CLI. So now we'll pivot a bit and go back to take a look at how we do this in the cloud.
Excellent.
So within the same federated inventory, let me shift over a couple of tabs here into the VPCs. Okay, so I don't know all these VPCs by heart, but I do know that this particular VPC is in AWS, and we can load its configuration up, and we can take a look at how it's configured. So again, we're doing an API call to ask AWS, this is a very specific VPC. Can you describe it for me? And these are done through API calls, not through CLI. But we can still gather information on how this is configured. So I'll point out a couple things like I did for the CLI's part of this. I'm going to take a look at internet gateways. For every VPC, you can have an internet gateway defined, which essentially just allows your VPC, which is essentially a private network inside AWS, to be able to speak, to communicate on the internet. So if you have an internet gateway defined, that gives it that ability. And an internet gateway, you can have multiple internet gateways for your organization. So we'll take a look at that and put that into a golden configuration standard. Another one that always comes up is security groups. For a VPC, you can actually have one or multiple security groups applied that very similar to what we looked at with the Cisco CLI configuration, where you can define security parameters to determine who can access devices within this environment, or who can manage that particular device. Security groups do the same thing in a way. So being able to create a golden configuration for a VPC with security groups becomes very, very valuable and useful. So let me hop over to the golden configuration and let's take a look at what we've defined here. So again, you'll see that we have the tree situation here, but I've kind of done things a little bit different here. I've broken this up into the two particular features. The internet gateway itself is one piece. So I've extracted the relevant configuration from the VPC that we just looked at in the device and the device configuration. And I've extracted just the relevant piece for the internet gateways. And the key component here is that currently our standard defines that this very specific VPC must have this internet gateway defined to it. Now, what if we decided at a point to change that, right? We've defined a new internet gateway, maybe for security purposes. Maybe we've tightened this thing down. It's possible that we now need to update our standard and say, instead of this particular unique internet gateway, when you spin up an internet gateway in AWS, it kind of gives you its own unique name, but maybe that unique name has changed. And now this is the new internet gateway. And now if I save this, this becomes part of the standard. So this particular VPC, or it could be multiple VPCs if we defined them to be part of this configuration tree, when they're compared to this configuration this golden configuration, they must have that. And so instead of assigning a device, because in the world of cloud networks, it's services and not devices, we're defining an API call to ask to describe that VPC, this very specific VPC that's used in our SE demo environment. And that's where the configuration comes from. So it's not a CLI configuration. It's like the API configuration we looked at. And so since this is applied to this particular branch, if I run a compliance on this, we can very quickly see, okay, because we updated the internet gateway and the VPCs, the internet gateways changed for this VPC, we can take a look at the compliance report and see what was out of compliance. And again, it's pointing out the path of the configuration, which is indeed the internet gateway ID. So it found that, and that's where it gave us our failing mark. So it's very similar to the way we do it on the CLI side. We can pull the configuration, but it's the configuration is through an API. It's configured in a way, or it's represented in a way that's in a JSON object, but you can still pull out very specific parts that are part of your policy. And the second one here is being able to identify security groups. So Glenn, remember a long time ago when I added the ACL, the access list on the CLI device for 10.0.0.99, because that's our secure jump box?
Seems like ages ago.
Seems like ages ago. Let's do a something very similar. So in a security group, we have this definition, but now we can tighten our security in the VPC and say, only that particular device, 10.0.0.99, I'm going to give it a subnet of 32, which is just a host. That's just that one host, is allowed ingress into this VPC. So within the security group, we have the ability to define these things. And this could be, like I said, a way to tighten down security. So I've just updated this golden configuration for this VPC. And now I could run a compliance check just like I did earlier. But again, how do we transition from here and then go into automation? Oops, there we go. And so I have an AWS VPC compliance workflow. It's very similar to the other one, if you notice. We're going to leverage the compliance report. So everything that we've done in Configuration Manager, we're leveraging all of that. So we built the golden config, we updated it there. Now we're just going to run a configuration based off of that golden config for those devices on that, or that VPC on the tree. We're going to query, we'll wait to get the response, we'll get the reports back, and then we'll be able to do the same thing, view the data and see the compliance output. Okay, so and just like previously, we can visualize this and see it running. So it's run the compliance report. It's doing a quick pause here so that the reports are done. And then It's stopped at the view data. Again, this is something we purposely put in so that we could stop it. But of course, this could be a whole bunch of logic to determine based off of the compliance report what exactly needs to be done. Could be anything from, automatic remediation. It could be opening up a ticket in ServiceNow. Could be notifying a group through some sort of messaging, Microsoft Teams or Slack. Could be all of those things. So if I go to my manual tasks, and then we'll take a look at the output from this, and it's going to show me the output of the compliance check. Again, it's in a JSON format, but as you can see, it aired out on two things. Number one, remember the internet gateway.
Right.
And then number two, we've added IP ranges for the security group. And again, we have the option, a lot of flexibility here within building your automations in the workflow on to remediate or not to remediate. And then we'll just continue on and see how the path went all the way through.
Excellent. I really like this, Rich, and I hope our viewers and listeners will see the power of this. I mean, essentially, what we're showing you is a really simple demonstration, but imagine this scaled out to hundreds or thousands of devices and or VPCs, or perhaps both. So when you talk about a modern network, like we were displaying in that image earlier, and you think about the complexity and the size, and you can certainly see how something like this would really streamline compliance across a hybrid infrastructure network. Okay, well, that's all we've got for today. We discussed those two major components. I'm just going to flip back to that slide really quickly. In the demonstration, we covered the ability to create and enforce a golden configuration across CLI devices and cloud network elements. And then we also showed how we can automate remediation of compliance issues found. So what about this third one? Well, I'm glad I asked myself that. We're going to be covering that in deep detail in part 4 of this webinar series, which will be on Tuesday, October 26th. So we hope you'll join us for that one. Validation is an extremely important part of this. Of this compliance journey that we're all on, and so we hope you'll join for that, and we'll demonstrate that in deep detail. All right. Just want to splash this up here really quickly. Feel free to get to itential.com/free trial and try Itential yourself. That's how you do it. So let's take some quick questions here. I see we have a handful of them up here. So let's start with this one, Rich. Do I need compliance if we have created immutable cloud infrastructure? Would you walk us through that and maybe tell us what we mean by immutable?
Yeah. So in the world of cloud, especially on a cloud ops team, the concept is that immutable infrastructure is once you spin it up, it shouldn't be modified. In fact, and if you don't need that anymore, you tear it down. And if you need something slightly different, you spin something back up. This is the whole concept of the cloud is all about spinning things up and tearing things down very quickly, right? And automating all that. And that's a great concept for a lot of what goes on in the cloud. But if you start to take a look at the level of complexity in the network, you don't want to tear down things. So the first thing I think of is like a transit gateway. A transit gateway can connect all, a bunch of on-prem stuff, a bunch of VPCs, even connect things through, to other cloud platforms. And you wouldn't want to tear that down to add a new VPC to it. That would be very disruptive. So, you still need compliance. So point number one, not everything can be immutable, especially in the world of networking. And point number two, when something is spun up in an immutable way, it could be that configuration. Let's take networking, for example. If it spins up some VPCs, it ought to be compliant at that moment. But just as we've just seen, your compliance rules, driven by different policies, could change over time. And so you would still need a compliance check across that immutable infrastructure to ensure over time it remains in compliance. And then, if the concept is immutable, then, maybe they tear that down and spin something up net new, but now it is adhering to the compliance of today, not of whenever they spun it up. So you still need it. That's still important. And not everything will be immutable in the cloud, especially when you look at more complicated networking.
Fair enough. Here's a good one. Can an automation include compliance checks for both CLI and API networking?
Yes, you can. So yeah, we split that up specifically just to show, in a very simplified way that you can do an API and a CLI. But we could have easily had a single workflow that included a CLI check and an API check. And that becomes interesting because maybe you have a service that transits on-prem with CLI devices and in the cloud with API services. And you could build a workflow very easily to do a compliance check across all the devices and services in the network for that service.
That's great. Well, we have a couple more questions, but I think we're running short on time here, so we'll answer those via email. Thanks to all of you for attending today. And as I said earlier, October 26th, we will have part 4 in this series where we will do a deep dive on the validation component of modern network compliance. So join us for that, and thank you for joining us today.